Hello everyone. So today is day 53 around. It has been quite a long time since I have uploaded any DSA video. So I was also solving CSES problem set. So these are the problems I have solved yet. And today only I solved three problems like gray code, Tower of Hanoi, creating strings, Apple division, chessboard and queens. So my friend Devraj is actually uploading all the solutions with the explanation, everything on this channel only. So please do visit them. Like if you will learn a lot from them. I'm going to share my method or what I have done on a very like high level overview, and also these two puzzles were the puzzles I solved today. So let's quickly just have a quick overview over them. The first puzzle was the shopkeeper and the lady who made a purchase of 200 fake note. So the question asked was how much loss did the shopkeeper face? So I was a bit confused when I tried to solve it with my head only. But like when you just go in that concept, like if you want to get the loss or profit, so let's say there's an initial state S1 and there's a final state S2. Simply get the difference from those. Think of like that. We have some initial state, we do something, some process, some transformation, and we reach to S2. Now you want to know what changed. Just simply do S1 minus S2 for a certain entity or whatever you want to do. So here, if you define the initial state of this customer shopkeeper, and after all the transformation we have, we go to S2, I can simply see the change. If we see the change, we can simply get loss or profit, whatever we have. So that way was much easier, like much easier to understand and also to generalize. So okay, try this and think of what I have said. This is chain link puzzle. Spend some time on it, you will surely get the answer. Just try to be innovative and creative and whatever ways you can think of. Okay. So in CSS problem set, the first one was gray code. So here basically, let's say the input is 2. So we have to print all the binary string combinations, but the condition is the difference should be 1. So 0 0 then 0 1. Here difference should be 1. So this is a condition. Press print a list of all 2n bit string of length n where any two successive string differ in exactly 1 bit and their Hamming distance is 1. Okay. So I was not able to solve this. So I checked the solution for this and I came to know that it could be solved using recursive way. So what I did was is define the base case for 0 and 1. Okay. And when we call it recursive function for n, then we stored for n minus 1 in previous string, we reversed it. Okay, this is the reversal part, and later we added 0 and 1 to 1 to 0 and 1, like these two characters, to our 0 was added to previous index. Okay, and 1 was added to the new string we defined, and next they're simply pushed to the vector string we defined. Just try to think on it, like you will find also some GFG article on that, so you can also refer to that. Okay, so this is just one of the path you can take and try to visualize, like test some test cases, like for n is equal to 1, n is equal to 2, n is equal to 3, 4. You will see you're able to generalize it. Okay, so I tried both this 0 and 1, both were able to work. Okay, so just I think what you need to remember is go for a recursion loop and think of this part, like we need to add 0 and 1 and how we need to add. If you can think of that part, think it will be very easy. Next was Tower of Hanoi. So here we need to do two things. We need to first print the answer, like how many, okay, number of n, how many steps will be required to get from certain state A to final state. So that was easy for me. Like I actually did that. That was not difficult, but I had to print also like the intermediate steps. Like you move the test from 1 to 3, 1 to 2, 3 to 2, and that part I was facing difficulty. Okay, so I checked the solution for that, and it quite came out very simple, like a very innovative, not innovative, like a very basic but good approach. So just think of this part. So here we moved from to helper using. So let's define the function first. So we define the function Tower of Hanoi. We have n. We define from helper to. Okay. So first what we did, we started from, we used to like the final state as helper, and we moved to helper. So we used to as the helper and moved to helper. And then we pushed this to result, like moving that actual disk. And then we moved the from, started from helper. So used from and to, and reached to 2. So started from, used to, reached helper. Started from helper, used from, reached to. So like just think of this part, you will able to understand what I'm actually saying. Okay. I try to visualize that part. So we have actually had a disk here. I think they will have a diagram. Is they? Okay, they don't have diagram. Try to think of this part. This part is very like, spend some time, you will actually able to do this. Okay. This was easy in that. Creating strings. Okay, so one of the method of doing so is like using recursion. Okay, so other method could be, this is very interesting. So the concept of next permutation. You can simply use next permutation to get the next permutation of any string. So yes, knowing this was like, was not aware of this beforehand. So yes, I learned it. I was not able to solve it initially, so I just referred to the articles only. So then I came to know about this. I just implemented and things worked. And also good thing to know, yeah, because many times we will work with strings, and if you need to get the next permutation, it's good to know the STL. And then we have apple division. So here basically we were given an apple of known weights. We have to basically divide this into two groups, such that the difference between these two groups is minimal. Okay. So basically I use the simple recursive function. Oh, and the condition here was n less than 20, so things work very fine. But if the n was long, we have to think of some other way. I use simple include exclude principle, include exclude, and finally in the base case, while I saved the answer. Okay, minimum of answer and the difference between these two. And I also stored a total sum, because once we have total sum, we can use a number of time. These were things to remember. Okay, and if we have initialize long answer, we can keep L long max. Okay, generally we do start with int answer, we do int max. Okay, but if we have long answer, we can do long max, L long max. Great. This was standard problem, chessboard and queens. We already have solved this like in recursion. But only difference was that initially few of the places were, like you can say, we can't use those places. So we can initialize our grid or whatever we are defining chessboard. We can put -1 or cross whatever we use. If you look at my solution, I think I started with -1. I love that. So where was star, I did -1, and where there were not star, I kept 0. And I only traversed when things were 0. Okay. And also while handling part, like it's a bit like a backtracking you can use, say, but if you think it's like very simple recursion, okay. Backtracking is just a like term to make things difficult. Otherwise, things are only recursive only. Okay. You need to think, because if you're moving the step back, you need to remove the traces or remove the part you have done. If you think of that way, you'll find able to solve this. Okay, these are the things I did today. Okay, then see you on some other day, maybe solely tomorrow. Bye bye.